Hello, just as a quick introduction, I was contracted to create a training simulation for staff in less technical positions at an industrial plant. The goal of the project was to demonstrate how VR can be used to structure training simulations and to focus on the feasibility and cost analysis of creating a close digital twin of a real-life plant. So, in a nutshell, the project was supposed to tackle 1. The feasibility of a close digital twin of a real-life plant from images and CAD data. 2. A cost analysis / workflow optimization of this particular project and potentially a larger scale project. 3. Allow users to navigate the plant easily in VR and inspect equipment names and details. And lastly, fetch equipment names and details from a BIM model and set up a framework to allow interchange of data between the two. Now for some background on the whys of the project, why it matters, and some of the challenges I faced. Extended reality and particularly virtual reality has received a lot of interest recently, partly as a result of its link to Meta, the largest company in the sector, the metaverse and Web3. While some of the displayed use cases are tenuous at best from my personal perspective, the technology has some undeniable advantages, particularly in training, education, digital twinning, and scenario simulation, which I got the chance to work on this project and I'm hoping to do more of in future. Had a few challenges on my table as soon as I took on the project, namely 1. Recreating a digital twin of the plant that was relatively realistic and within a reasonable time frame. 2. Handling the large amount of data that was required just to build the project. 3. Delivering the project within a reasonable time frame with certain personal constraints and with the restriction of working as a one-man team. 4. Another pain point I had to deal with, hardware. My Quest 2 had its port burnout during the project, as you can see on the screen, a design flaw that in hindsight would have been easy to mitigate by tying down the cable onto the side of the strap interface, but unfortunately hindsight is 2020. And lastly, and probably one of the most frustrating parts, a combination of software and hardware issues. I faced a number of issues with handling the project data, from corruption to outright losing days of progress, to drives dying and issues with Unity not opening up a previously working project file for some reason. That aside, onto the approach I decided to take to tackle the project. Creating a digital twin from the CAD data provided was the most significant challenge facing a timely delivery. CAD data is notorious for being unusable in traditional 3D workflows, particularly in real-time ones, which necessitates a remodel from scratch using the data just as a reference. To address this, I relied heavily on procedural and non-destructive workflows, both within Blender and in Unity. Some of the tools I used were geometry nodes. It was really helpful. The modifier stack to be able to perform operations non-destructively, and Python scripts to automate duplicate object placements and meshes with similar geometry. I worked on creating the valves and making sure they were as optimized as possible, as you can see on the screen at the moment, without compromising quality and not using textures where possible to reduce the memory requirements of the final application. The application was built to run on desktop using a Quest 2, but with the ability to use the Steam VR runtime, opening up the choice of headsets that could be used to experience the application. This approach was overall effective and enabled me to deliver a working prototype that met the client's expectations. However, I did grossly underestimate the amount of work needed, and the project setbacks pushed the timeline much further than I expected. But the results were promising, and the VR simulation prototype was successful in meeting the client's expectations, which is really important, despite the challenges encountered during development. I was really pleased with how the project demonstrated how easy it is to learn a spatial concept when training actually takes place in a spatial environment. And on to the conclusion, the biggest lesson I learned from this project is the importance of redundancy in both hardware and data. A network-attached storage would have been really helpful in ensuring that the project was backed up on a regular schedule. Battery backup power would also have been helpful to ensure that power losses during crucial operations didn't lead to data corruption as they did. And having a backup Quest 2 would have saved me a lot of travel. Moving forward, I'm hoping to have the opportunity to develop this project or another into a full training simulation. The plant, as a consequence of the amount of playtesting and development time that I have on the project, has been burnt onto the back of my mind. And I believe VR can make training and education way more effective by providing a spatial environment for learners. And lastly, here's a short walkthrough of the application, so showing as much of it as I'm allowed to share, and with a demonstration of some of its functionality.
Hello, welcome to this virtual training simulation. Please use the panel in front of you to navigate.
So as you can see, this is by pressing the grip button. This is how your hands look when you press the grip button. This is what happens when you press this is what happens when you press the grip button, and what happens when you press the trigger button. In this instance, you can see the control scheme right ahead of me. This is for moving around the joystick. The wrist menu can be brought up by pressing down the options menu on the controller, and the properties menu can be brought up by pressing the B button, the A button on the controller. In this instance, then you can interact with the menu by pressing the trigger button on the right hand controller. And the quest menu can be brought up by pressing the quest button, and this is for turning. The right joystick is for turning, and the left grip button is for teleporting, while the right trigger button is what you'll use to teleport. So right now, as you can see, there's this panel ahead of me. I can start, but I can
Please use the orange markers on the map to select a teleport location.
Yeah. So I can point to one of these, and as soon as I press the grip button on my right hand, so that you should make a fist when you do so. The grip button on the right hand and point at the specific area I'd like to teleport to. I'll be teleported to that particular location, as well as if I go to the start menu, you can go to walkthrough to get started with a map that will walk you through the controls and everything that you need to be able to walk through a scenario. Then start will just take you right to the beginning of the map at this particular point here, and then from there you can get started. Then exit, then you can confirm to leave the map. So right now I'll just get started with the walkthrough first. So here's an example of the revised interactions on the valves. As you can see, the first scenario is going to this particular location where the marker is, and then
please review the valve tags in the marker area and their respective statuses by pointing your controller at the respective valve. Once you're done, proceed to the next marker.
You can see you can interact with the valve to get the details. And now we'll go to the next scenario, which is where we will actually interact with valves. So in this instance, we have so as soon as we'll enter the marker, we'll get instructions on what exactly we need to do.
Close the spec blind and review the valve tags in the marker area and their respective statuses. Once you're done, proceed to the next marker.
As you can see, the valves we ought to interact with are highlighted. I highlighted this one so that we can also demonstrate how that one works. So in this instance, as soon as I get close to it and I touch it, then press down, and I have to press down all the way through for it to slowly turn and get into position. So as soon as it's done, it turns red, shows you the status. The next valve that you ought to interact with is highlighted. As you can see, when I interact with that one, the next valve that it ought to be interacted with also highlights. And if I was to demonstrate how the interaction function on this one also works, I need to press the grip button and hold it down through the rotation period of the valve, and also keep my hand inside. The moment I remove my hand, it will stop rotating. Put your hand in again, it keeps rotating. In this instance, I just hold it down. Need to keep holding it down. It will slowly rotate, and until it's done. Then when it's done, it turns green. As you can see, that works seamlessly. Hold it down, rotates. As soon as it's done rotating, it turns off. Same goes with these ones as well. You can see, then turns red. If I grab it again, turns green. So in this instance, I'd actually like to interact with this valve. So as you can see, I can grab this, press it down, wait until it finishes rotating. As soon as it's done doing so, the valve status will change to red. As you can see it now, the valve status is now changed to closed. As you can see, this particular valve doesn't have a specific name, but you can see the status is changed to closed. Then the next valve in this instance is highlighted, showing me which valve I ought to interact with. So as soon as I press down, hold it down, done rotating. And as you can see, if I was to check the status, now closed. If I was to check the status of this, it's open and it also has a name. That's helpful. At the same time, also these other valves are working, but I've just kept the highlighting situation to the valve that you ought to interact with. Hold it down, slowly rotate, turns green. Hold it down, slowly rotate. You have to keep holding it down until it finishes. So yeah, turns red. And as you can see, this is the last valve in the scenario, and then we'll go to the final, then we'll go to the next. So once that's done, and as soon as we leave the area, as you can see, the valves are no longer highlighted, showing us that we are done with the scenario, and we can also pick the scenario that we need to go to, the next scenario, which is this. Well, that's mostly it for some of the features I'm allowed to showcase. A few other notable things I'd like to make sure I highlight are probably the fact that I used AI to generate the voice prompt that you hear in the training scenario that prompts you to take certain actions. It was generated using Microsoft's cognitive services, where you can use a text-to-speech service which you can use to generate human speech from text. Thanks for watching. That's pretty much it.